Okay, today we're looking at solving exponential and logarithmic equations and inequalities. We're going to find this one a little bit challenging. So a little bit of a reminder of the properties of exponents and logarithms that we've seen so far. Put this in as a handy reference guide for the different exponent laws and laws of logarithms. We are going to be solving inequalities and giving our answers in exact form. So let me solve the first one for you. We want to get x on its own. So typically with equations like this one, you're going to aim to get it into the form b to the x is equal to y, so that you can rearrange into logarithmic form and get x is equal to log base b of y. So that's kind of our goal for this type of equation. So let's just start off by moving the 2 across. We'll get 9, and then we can say that x is equal to log base 4 of 9. Okay, pause the video and have a go at these two for yourselves. Okay, welcome back. So let's try that technique again here. We'll start off by moving the 5 across. We'll get 21 is 2 to the x plus 3. Then we'll convert to log form, and we get x plus 3 is equal to log base 2 of 21. And then we can subtract the 3 across. We get log base 2 of 21 minus 3. So here on this one, let's start off by moving. I think I might like to just move the 4e to the x here and add 7 to both sides, make everything positive. That seems like a nice start for me. We get e to the x is equal to 5 over 2. And then we want to take ln of both sides. We get x is equal to ln 5 minus ln 2. We can either answer like that or like this. Both are acceptable. Okay, example 2. So with this type of equation, we want to we'll just move it around and see what we get to begin with. So I'm going to take log base 3 x plus 3 is equal to 6. Log base 3 x plus 3 is equal to 4. Oh no, sorry, not 4. I'm subtracting. I'm sorry, we want to divide by 2. Sorry, I'm a bit ill today. I'm not at my best. All right, so there we go. We can see that one quite easily. We can convert now using the laws of exponents. So x plus 3 is going to be equal to 3 to the power of 3. Converting now at this point the other way. So if we get it into the form log base b of x is equal to y, we can then move it across into x equals b to the y. And that's what I'm doing here. So then we've got x is equal to 27 minus 3. And that should give us 24. Have a go at these two. Pause the video now. Have a go at these two for yourself. Okay, welcome back. Yep, so let's go for log base 5, 2x minus 1 is equal to 2. So 2 to the x minus 1 is equal to 5 squared, which is 25. Then we can 2x is equal to 26, x is equal to 13. So now at this point, you want to start just checking for extraneous solutions a little bit. we've got x equal to 13 here. I'm just putting in 13 there and making sure it's not negative. It's not. We get 26 minus 1, 25, no problem. Let's try this last one. Talk more about extraneous solutions in a minute. So let's rearrange it. We get ln 2 minus x is equal to 5. And then 2 minus x is equal to e to the 5. So simply we can express x as, just move that way. We get 2 minus e to the 5. Okay. Right, so here we're starting to look out for extraneous solutions. Now these are ones that will be not defined for the given expressions that we're working with. So for instance, if we look at the expressions that we've got in this first one, we can say that x has to be greater than, so minus 4. So x has to be greater than minus 4. And this one is x has to be greater than 2 over 5. So this one doesn't really matter because this one supersedes it. So you need to watch out for that. Okay, let's put it together a little bit. We can use one of the laws, put this together into a single logarithm, and we get 3x plus 12 is equal to log 5x minus 2. Now we've got two logs on either side. We can just take them away because the inner part of this bracket has to be the same as the inner part of that bracket because you have the same function on the outside. So this is going to give us 3x plus 12 is equal to 5x minus 2. Bring the x's across this way, we're going to get 2x, and bring the numbers this way, we'll get 14, x equals 7. Check for extraneous solutions. Is this bigger than 0.4? It is. No problems with that one. Have a go at this one now for yourself. Pause the video. Okay, so yeah, we want to join these together, I think. Oof. So we are going to get ln, I'll use a bracket for this one, x plus 1 all over 3x minus 5 is equal to ln 7. So x plus 1 over 3x minus 5 equals 7. X plus 1 equals 21x minus 35. That's 36 and 20x. So x is equal to 9 over 5. Now that's equal to 1.8. Let's have a look. So x is greater than negative 1. X here has to be greater than 5 over 3, which is equal to 1.6 recurring. So we are good. It's slightly higher. All right, let's have a look at example 4. All right. So x is greater than 0. X is greater than negative 7. So x is greater than 0. This is going to give us log base 4 of x over 2 to the power of 3, which is 8, is equal to log base 4. Nice, they're both the same logarithm, x plus 7. So x over 8 is equal to x plus 7. That means we get x is equal to 8x plus 56. So minus 7x is equal to 56. X is equal to 56 over negative 56 over 7, which is less than 0, which implies no solutions. So we get a solution there. You should always find your solution, but then if we compare it to this part of the domain, this is not possible. We just put that minus sign in there a little bit bigger. All right, have a go at this one for yourself. Pause your video. Okay, let's have a look. So we can see here x is greater than 7 is the domain for this equation, because this one is x is greater than 0. Okay, so I was just considering whether I was going to turn that 2 into a log. I could have a log of 100, but I think what I'll do is I will move it around like this. Log of x minus log of x minus 7 equals 2. So we get log of x over x minus 7 equals 2, and then x over x minus 7 equals 100. Rearranging, we get x equals 100x minus 700. X equals 99x equals 700. X equals 700 over 99. Which is roughly 7. Compared to our domain. Oof. So when I say it's roughly 7, is it bigger than 7? Yes, it is. So just a little bigger than 7. If this denominator was 100, it would be 7. If it was 101, it would be less than 7. And at 99, it's just more than 7. Okay, so we've got 2 functions, and we need to find all the values of x where the graphs f and g intersect. So this, if f of x is equal to g of x, it implies that ln x plus 15 minus ln x is equal to ln x plus 3. We need to create one logarithm on each side, then take it away. We'll get x plus 15 over x is equal to x plus 3. Rearranging that, if we move the x up, we get x plus 15 is equal to x squared plus 3x. So x squared plus 2x minus 15 is equal to 0. And then factoring that, we're going to get x plus 5 minus 3. Yeah. X minus 3 is equal to 0. This gives us x is equal to negative 5, and x is equal to 3. Now, let's have a look at our domain for this equation. So the domain here is x is greater than negative 3, and x is greater than negative 15, and x is greater than 0. So this is the important one. X has to be positive. So we could say as x is greater than 0, x equal to 3 is the only solution. Okay, so now it gets a little bit trickier. We've got an inequality to solve here on this one. And right. So if we want f of x to be greater than 0, that means the logarithm of x squared minus 4x plus 7 minus the logarithm x plus 3 is greater than 0. Now, with inequalities and logarithms, take care, if you can, avoid multiplying by expressions of the form logarithm of x. So for instance, when you multiply both sides by this expression, you have to change the direction of the inequality, because this expression is positive for x is greater than 0, and it is negative for x is less than 0. So this expression, if you were to multiply through by something like this, you would have to split it into two equations with different domains based on what makes the sign change inside. And then that would cause you to change the direction. Sorry, I got that slightly wrong. It's 1 when x is greater than 1 and when x is less than 1. Let me explain that a little bit here. So the logarithm function looks like this. And here at this point at 1, 0 is where the function's value, which are these y values here, change from negative to positive. So here it will be negative, and here it will be positive. So if you're multiplying by an expression like log of x, then when x is greater than 1, you're multiplying by a positive, you don't have to worry. When x is less than 1, you multiply by a negative, so you have to flip the direction of the sign. Take care with that aspect. I'm not going to have to do that here. I can just join them together. So this gives me the logarithm of x squared minus 4x plus 7 all over x plus 3 is greater than 0. So when is a logarithm function greater than 0? Well, when the function is going to be bigger than, when the x value is going to be bigger than 1. So that means that this expression here, x squared minus 4x plus 7, we want to look to see where this will change and become 1. So if the internal expression inside the logarithm function is bigger than 1, the logarithm is going to be bigger than 0. So if the inside, which is the x value in this direction, when the inside switches to be a value bigger than 1, the function on the outside will also switch to be a positive. X squared minus 4x plus 7 is bigger than x plus 3. Let's rearrange. We get x squared minus 5x plus 4 is bigger than 0. So now we want to factor that, and we get x minus 1, x minus 4 is bigger than 0. Now let's do a little sign line. Like this. Okay, so what is our domain of our equation? Well, we can see here that x has to be bigger than negative 3. And this numerator is going to flip in 2 places. So I'll leave that one off for now. So we want to go from negative 3 and then up to positive 1 and then up to 4 and see what happens. So this term is going to be positive when we're bigger than 1. Otherwise, it's going to be negative. This term will be positive here. So the function will be positive, the terms will be positive there and there and there, and here they will be negative, and here they will not be defined. These terms are not going to be defined due to this in the domain. So our function, we want the function to be positive, so the result in all of this is it's going to be positive here, negative here, positive here, and not defined there. Let's turn that into an inequality. So we want our solution to be minus 3 up to 1 and x is greater than 4. In interval notation, minus 3, 1, union 4, infinity. Right, that's it for today. Just do a little bit of a zoom in here for you guys. So there we go, there's the solution. There's the examination of the signs, and then the final answer.